Welcome to Hub History, where we go far beyond the Freedom Trail to share our favorite stories from the history of Boston, the hub of the universe. This is episode 287, A Blizzard of Falling Stars. Hi, I'm Jake. Before dawn on November 13th, 1833, Bostonians awoke to an unexpected light in the sky. Some began their morning routines, thinking that the sun had risen. A few dashed outside to douse the fire they expected to see consuming a neighbor's house, and some simply looked out the window in curiosity. When they looked up to the heavens, they saw an unparalleled celestial spectacle. A meteor shower of unprecedented intensity erupted in the night sky, filling it with tens of thousands of shooting stars per hour. Star Wars fans might picture the Eye of Aldhani from Episode 6 of Andor, a spectacular feat of special effects that allowed the protagonists to make their escape from the Empire during a meteor shower that lit up the night sky. The real 1833 meteor shower was no less spectacular. That phenomenon, which came to be known as the Leonid meteor storm, was one of the most remarkable astronomical events in recorded history, both because of its breathtaking beauty and its importance to the development of science. But before we talk about the blizzard of falling stars in 1833, I just want to pause and thank Douglas C. for his recent generous gift on PayPal. I usually promote Patreon because it provides ongoing support for the show. However, for anyone looking to give us a one-time gift, PayPal is probably the option you're looking for. Whether you prefer a one-time gift or an ongoing sponsorship on Patreon of as little as $2 a month, listener support is what makes it possible for me to go on making the show. Your generosity covers the ongoing expenses of making a podcast, things like hosting, security, and equipment costs. To all our existing sponsors, thank you. And if you're not yet supporting the show and you'd like to start, just go to patreon.com/hubhistory or visit hubhistory.com and click on the Support Us link to give on PayPal or Patreon. And thanks again to all our new and returning sponsors. Now it's time for this week's main topic. It's hard for me to imagine what it must have been like to witness the 1833 Leonid meteor storm, both because Boston's night sky is so bright today that it's rare to see a shooting star at all, and because modern science and media combine to hype up any upcoming astronomical events for the public. After all, I did just get back from flying almost all the way across the country to be able to see the annular eclipse under desert skies. However, at the time, there was no notice of the upcoming meteor shower, so people who witnessed it didn't immediately know what to think. An article from the November 14th, 1833 United States Gazette gives a sense of how shocking the event was. A friend assures us that when the meteors first met his eye from his bedchamber, he believed that there were sparks from his own or his neighbor's house on fire, and he rushed out to ascertain the amount of danger. He no sooner reached the yard than, turning his face upwards to discover what roof was on fire, the heavens, resprinkled with their new glories, met his eye, and for a moment it seemed as if the stars were realizing the sublime conception of the poet and were praising their creator. Imagine how shockingly beautiful it would be to open your blinds and see stars falling from the sky as thick as snow. It sounds like hyperbole, but that's exactly what one Bostonian described in a report on the meteor shower that modern scientists consider one of the most accurate and reliable, as published in the newspaper The Columbian Sentinel. Having risen as usual at 4 o'clock, I thought I observed several very bright falling stars, but as the window was covered with steam in consequence of the change in temperature out of doors during the night, I saw but indistinctly, and took my box to strike a light without seeing or thinking more of the phenomenon, until I went down to the parlor 20 minutes before 6 o'clock. Except that twice I saw a very sudden and bright glare of light, which, at the time, I suppose must have come from some lamp or fire in the house opposite. On opening one of the parlor shutters, I was surprised at seeing innumerable meteors similar to those commonly called shooting stars. They were moving in a direction downward, and I should say, according to the best judgment I could form, were falling about half as thick as the flakes of snow in one of our common snowfalls, with intervals of a few seconds when there were not so many. Not only were the nights darker back then, but the meteors were more impressive too. On the rare occasions when I see a shooting star, and not just a combination of a satellite and wishful thinking, it's almost always a fleeting streak of light that I just catch from the corner of my eye. There was one time, back in December 2014, when I saw a huge blue-white ball trailing orange sparks. And it sounds like that once-in-a-lifetime experience was typical of the 1833 Leonids. The November 13th Boston Transcript reported, "This morning, between 3:30 and 4:30 o'clock, there was a war of shooting stars in the northwest. For an hour, meteor succeeded meteor in such rapid succession that it was impossible to count them. At times, the sky seemed full of them, and the earth was illuminated as with morning light. They shot in each direction, principally, however, from the southeast towards the northwest, and 4 or more appeared lower than 25 degrees from the horizon. They were many thousands in number, and as they shot from one part of the heavens to the other, they would burn like rockets, discharging balls of fire in all directions. The morning was dark, and the atmosphere clear and cold. Those who were so fortunate as to witness the scene describe it as brilliant beyond conception, far surpassing the most costly artificial fireworks." Of course, not everyone was transfixed by the sight of the meteors. I thought the diary entry that John Quincy Adams wrote the day after the meteor storm was funny, though I'm not 100% sure whether he witnessed it from Boston or from his congressional office in D.C. I awoke twice this morning before I rose. The second time, though a little after 4 and without a moon, the atmosphere was lighted as by a twilight, and I observed an unusual succession for several minutes of the meteors called falling stars. As they seemed then to cease, I paid no further attention to them, but learnt from others that they continued with increasing and most extraordinary brilliancy. Doesn't that tell you everything you need to know about old JQA? Sees the light of falling stars, and barely even glanced out the window. I had never heard of the 1833 meteor storm until recently. In the wake of last year's Leonid meteor shower, during which I saw 0 meteors, I stumbled across a link to the account in the Columbian Sentinel that I just quoted from. At the time, the episode of Andor featuring the Eye of Aldhani had just aired, so it was fresh in my mind. For anyone who hasn't seen it, the Eye of Aldhani is a massive meteor storm in the Star Wars TV series Andor. In the show, the event occurs once every 3 years and appears in the sky like a giant eye, so bright and spectacular that it could be seen from all over the planet Aldhani. The event's sacred to the native Aldhani people, who believe that it's the manifestation of their gods. They gather to witness the event every time it happens, and celebrate it with festivals and rituals. In the show, a small group of rebels plans to use the event as cover for an operation, knowing that the Imperials will be distracted by the Eye of Aldhani in the presence of reverent locals, and they hope to be able to escape before the Imperials realize what's happening. One episode in the series climaxes as the rebels take off in a stolen ship directly into the light of the stars falling around them. I didn't realize until reading more primary sources just how close to a real meteor storm the depiction of the eye actually was. The header image for this week's show notes will be an animated GIF of the eye, so you can see the image I had in mind when I started researching this episode. However, it turns out that there are parallels to real life beyond just the way the meteor shower looked. In the Star Wars universe, locals treated the eye as proof of a divine hand at work, and there are plenty of observers in 1833 who did the same. Yale physicist and astronomer Denison Olmsted wrote in a later report on the event, "Probably no celestial phenomenon has ever occurred in this country since its first settlement, which was viewed with so much admiration and delight by one class of spectators, or with so much astonishment and fear by another class." For the other class of Bostonians who witnessed the meteor storm, the sight of stars falling from the sky in a steady cascade seemed to fulfill a biblical prophecy of the second coming of Jesus, as related in the book of Matthew, chapter 24. "Immediately after the tribulation of those days shall the sun be darkened, and the moon shall not give her light, and the stars shall fall from heaven, and the powers of the heavens shall be shaken. And then shall appear the sign of the Son of Man in heaven. And then shall all the tribes of the earth mourn, and they shall see the Son of Man coming in the clouds of heaven with power and great glory. At the time, a new religious movement was growing in New England, and its adherents were especially susceptible to seeing signs of an impending judgment day. William Miller was a farmer, politician, and War of 1812 veteran who'd grown up in Western Mass, Vermont, and upstate New York. After an intense conversion experience, he became convinced that the second coming of Jesus Christ was close at hand. He published a detailed explanation of his reasoning from Scripture, and began preaching in a tradition that's today the Seventh-day Adventist Church. In a 1995 article about Miller's church and the meteor storm of 1833, David Hughes wrote, "In 1831, Miller announced that Jesus Christ would return to Earth in a physical body in the year 1843. He would then judge sinners and inaugurate the millennium. Adventists watched the skies for the second coming of Christ and believed that the apocalypse was imminent. They had a tendency to identify spectacular natural phenomena with the biblical prophecies that related to the end of the world. The observations of the Leonid meteor storm of November 1833 fitted superbly with the opening of the sixth seal. The sixth seal is taken from the book of Revelations, where it's the penultimate sign of the impending apocalypse that Christians believe will accompany the return of Christ. And it also contains references to falling stars. "And I beheld when he had opened the sixth seal, and lo, there was a great earthquake, and the sun became as black as sackcloth of hair, and the moon became as blood. And the stars of heaven fell unto the earth, even as a fig tree casteth her untimely figs when she is shaken of a mighty wind. And the heaven departed as a scroll when it's rolled together, and every mountain and island were removed out of their places. And the kings of men, and the great men, and the rich men, and the chief captains, and the mighty men, and every bondman, and every free man hid themselves in the dens and in the rocks of the mountains, and said to the mountains and rocks, Fall on us, and hide us from the face of him that sitteth on the throne, and from the wrath of the Lamb. For the great day of his wrath is come, and who shall be able to stand?" While the thoughts of some Christians turned to judgment and rapture, many more Bostonians stood transfixed by the sheer natural beauty of the phenomenon they were witnessing. Sidney Purley's 1891 Historic Storms of New England is my go-to source for all meteorological events in Boston from colonization up to that point, and it also contains accounts of celestial events, like comets, the aurora borealis, and eclipses. The 1833 meteor shower is no exception, with Purley writing, "The shooting meteors left luminous trails or traces of white light behind them of from half a yard to 3 yards in length apparently, which slightly curved downward and remained visible from 3 to 5 seconds. The meteors fell at times in such large numbers that they seemed like a shower of fire. Now and then, one much brighter and larger than the rest would shoot across the sky like vivid lightning. They fell about 1/2 as thickly as snowflakes fall in a common snowstorm, with intervals when but few could be seen. They produced a sound like wish, wish, gently spoken many times in different degrees of loudness. Great numbers were seen to explode like a rocket, sending forth trains of dazzling sparks, accompanied by an explosive noise. From time to time, a sound, as of a body rushing through the air, was heard. The meteors seemed to have distinct nucleuses about half the size of Jupiter, some being larger and some smaller. Later scholars have cast doubt on the idea that the sound of descending meteors would have been audible from the ground, but it was reported in several New England towns. The account that I quoted from in the Columbian Sentinel, which Professor Olmsted called "as exact an estimate as any we have met with," contains no references to a noise, despite exhaustive detail on the appearance of the display. There was but little wind, and this from the west. The direction in which the meteors moved was almost directly downward, and not oblique as usually seen, except in two instances when the course was horizontal, nearly in a straight line, and from northeast to southwest, and these two meteors were high and small. Generally, the meteors appeared to be very low in the atmosphere, some to come down apparently almost to the housetops. They all had a distinct nucleus, generally about half the size of Jupiter. Some were larger than this, some smaller, and a few were larger than the apparent disk of Jupiter. They all left luminous white traces, bands or tails, which generally appeared to be, in popular language, about a yard in length. A few were 3 times, and some not more than half this apparent length. Their appearance continued in most cases from 3 to 4 seconds, some 5. Not many, if any, longer than this. There was no appearance of explosion or bursting to the nucleus of any of them. The anonymous author says that 2 meteors in particular were bright enough to illuminate the steeple of a nearby church like daybreak, but he does not specify which church he was observing. Eventually, dawn began to break over Boston Harbor, and the rising sun eventually overpowered the light of falling stars. But nearly everyone who wrote an account of the show from Boston commented on the exceptional beauty of the final visible meteors as they fell through the warm light of sunrise. Sidney Purley commented, "At about 5:30, when they were flashing in the light of the approaching sunrise, the heavens presented one of the most extraordinary, beautiful, and sublime sights ever beheld by man." Along with commenting on the beauty of the last few meteors that were visible through the gathering daylight, our correspondent in the Columbian Sentinel appears to have had a scientific mind, which he, or she, turned to estimating the number of shooting stars that could be seen that morning. I stood observing the phenomenon till 15 minutes before 6, at which time, the meteors being fewer, I attempted to count a portion of them. In the part to which my attention was confined, and which was perhaps a 10th part or rather less of the horizon, I counted 650 stars during the 15 minutes before 6 o'clock. They fell so fast and thick, however, that I supposed I was not able to enumerate thus distinctly more than 2/3 the number of those which actually fell during the time in the space to which my attention was directed. If I'm correct in my estimation, this would show that the number of meteors falling during the 15 minutes to have been more than 8,660. At 6 o'clock, I went to the top of the house. The phenomenon was now beginning to cease. During the first 15 minutes after 6, the number which fell in the southern half of the heavens from the zenith downward was 98. The last fell 10 minutes before sunrise. Our anonymous correspondent isn't the only person whose mind turned to science after witnessing the meteor storm of 1833. Today it's remembered as a significant event in the history of science. The shower was the first major astronomical event to be recorded by a large number of citizens, and it helped to establish the importance of citizen science in astronomy. Before the 1833 Leonid meteor storm, astronomers had largely relied on their own observations to study celestial phenomena. Now, for the first time, scientists were able to collect data on a large-scale meteor shower from a large number of observers. This data allowed them to track the path of the meteors and calculate their speed and direction. It also helped them to understand the nature of meteor showers and the relationship between meteors and comets. One of the most important contributions to citizen science during the 1833 event was made by Denison Olmsted, a professor of astronomy at Yale University. Olmsted collected data from over 1,000 observers across the United States and Canada on the number, brightness, and direction of the meteors. He used this data to create a map of the meteor shower and to calculate its point of origin. Olmsted's work was published in the American Journal of Science, and it's considered to be one of the most important early contributions to the study of meteor showers. After being awakened by the light in the sky over New Haven, Professor Olmsted not only wrote to a local newspaper with his observations, he also asked for readers from all over to forward their own observations. As the cause of falling stars is not well understood by meteorologists, it's desirable to collect all the facts attending this phenomenon, stated with as much precision as possible. The subscriber, therefore, respectfully requests to be informed of any particulars which were observed by others respecting the time when it was first discovered, the position of the radiant point above mentioned, whether progressive or stationary, and of any other facts relating to the meteors. Denison Olmsted, Yale College, November 13, 1833. In a subsequent letter to the editor of the New Haven Daily Register, Professor Olmsted requests the favor of communications from those who witnessed the meteoric shower, and to state particularly from what part of the heavens the fireballs appeared to emanate, whether they all proceeded from the same point, whether this point was stationary among the stars and followed their diurnal motion from east to west, and near what particular star it was seen at different hours, from the beginning to the end of the observations. Should my observation that the origin of the meteors remained stationary, following the progress of the stars, be confirmed by others who saw it for a longer time, it would show that this point was beyond the limits of the atmosphere. For otherwise, it would have advanced eastward with respect to the stars, along with the atmosphere in its diurnal revolution. Moreover, the exact position of this point at any given time, as seen from places remote from each other, will, if correctly ascertained, afford the means by the parallactic arc of calculating its height above the Earth. As meteorological phenomena of this class are frequently attended with irregularities of the magnetic needle, should anyone have observed the state of the needle during its continuance, or should have detected any deviation arising from it, he would also confer a favor by communicating the facts. In the days before the Associated Press and other wire services, newspaper editors relied on a circular model to report on news from afar. Each editor would send the latest edition of their own paper to the editors of the other papers they partnered with, and they would all borrow from each other's reporting to be able to inform their readers of what was going on in the world. Olmsted's query had soon been circulated to every corner of the country, and even beyond. Editors from around the country passed on letters they got from ship's captains, reporting on magnetic anomalies they thought they detected on their ship's compasses when they saw the meteors during a transatlantic voyage. He got letters from plantations in the deep south, reporting on how the people who were enslaved there experienced the meteor storm. And before long, he got letters from other scientifically minded observers, reporting on everything from meteors that had fallen to the ground, to the sound of the meteors, to changes in the weather that were, probably erroneously, attributed to the meteor storm. This report appeared in the New Hampshire Gazette on November 26, 1833. About 2 weeks after the event. It is now beyond a doubt proved that solid mineral masses are thrown upon the Earth by the explosion of meteors. These mineral substances all resemble each other in outward appearance, and in their constitution. Their exterior surface is black, while the interior is of a yellowish white. They are composed of the same ingredients, united in nearly the same proportions, namely silex, sulfur, magnesia, iron, in a metallic state, nickel, and chromium. Now, iron is never found native, or in a metallic state, unless alloyed with nickel, and all meteoric iron has the same alloy. Iron in terrestrial bodies is found always oxidated. Nickel is never found on the surface of the Earth, and chromium is equally rare. These facts seem to prove that the stones and the meteors from which they are thrown have one common origin, and that this origin is foreign to our Earth. A reporter for the Newport Herald dug into past reports of meteoric activity from around the world and published this pattern on November 28, 1833. It is a remarkable coincidence that 3 great meteoric showers all took place on the morning of the 13th of November. In South America, November 13, 1779, at Mocha, November 13, 1832, and in the United States, November 13, 1833. Thanks to reports like these and over 1,000 others sent into newspapers around the country, Professor Olmsted was able to make some pretty solid inferences about the source of the shooting stars that the whole continent had witnessed. At that time, most people believed that shooting stars were a meteorological phenomenon. It sounds funny to us, but people knew that lightning was produced by the weather, including the rare ball-shaped lightning that sailors sometimes saw rolling down the lines of their rigging during a thunderstorm and called St. Elmo's fire. There was little reason to believe that falling stars originated outside our world. At least not until Professor Olmsted's paper. He published dozens of the reports that he had gotten from around the country, including his own, and then went on with his own conclusions, including this one. The meteors moved either in right lines or in such apparent curves as, upon optic principles, can be resolved into right lines. To some observers, they appeared to descend directly downwards, to others, to tend towards the northwest, and to others, to move in every direction. The meteors as seen by most observers appear to proceed from a fixed point in the heavens, which some referred to as the zenith, and others to a point a little southeast of the zenith. Those who marked its position among the fixed stars observed it to be in the constellation Leo, in which it appeared stationary, accompanying that constellation in its diurnal progress. This was an important point in concluding that the meteor storm originated from outside our world, and was not a product of the weather. If the origin of the meteors always appeared within the constellation Leo, no matter where in the country the observer was standing, and what the weather conditions and time of night in that place was, it couldn't be a product of local weather, or even a high atmosphere phenomenon. Only the stars stayed fixed in the night sky, and the origin of the meteors remained fixed with the stars. Olmsted continues, if the apparent radiant point from which the meteors proceeded was merely the effect of perspective, no inference could be made respecting the height of the region from which they came, as the same apparent convergence of the distant parts of parallel lines would be presented whether the lines were 1 mile or 1,000 miles in length. Such an apparent convergence or radiation in itself merely proves that the lines are nearly or entirely parallel. But if the meteors came from a region of space, being attracted towards the Earth by gravity, in lines directed towards the center of the Earth, and therefore within a moderate space parallel to each other, then the convergence of such lines to a focus would indicate the position of that focus in the heavens. And this position, being accurately noted by different observers, at places remote from each other on the surface of the Earth, the height of the place whence the meteors originated can be determined, unless that height be too great to exhibit any parallax. In the present instance, this does not appear to be the case, for the radiant point as observed by Dr. Aiken at Emmitsburg, and by the writer at New Haven, had a parallax of about 3 degrees 40 minutes in declination. It is to be remarked that, although the several observers who fixed the position of the radiant among the stars agreed in placing it in the constellation Leo, yet the distant observers did not assign it to the same part of Leo. At New Haven, it appeared a little to the westward of Gamma Leonis, having a declination of 21 degrees. His observations were published in the American Journal of Science and Arts in January 1834. But he also published a version of his comments meant for the general public in the New Haven Herald on November 14, 1834. Having watched the next year's meteor shower, which peaked on the same calendar date, he concluded that the direction of the lesser number of meteors was still enough to prove his theories, writing, "The directions of the meteors were more remarkable than their number, and afforded more unequivocal evidence of the identity of the phenomenon with that of last year. They appeared as before to radiate from a common center, and that center was again in the constellation Leo. In whatever part of the heavens they fell, their lines of direction would pass through that point. The attention of Mr. Loomis was particularly directed toward determining the position of the apparent radiant, having taken the bearings of a sufficient number of the lines of direction, and afterwards traced them on a globe. They meet near the lion's eye, declination 30 degrees 15 minutes, right ascension 144 degrees 30 minutes. The radiant point is therefore a little northward and westward of the place it occupied last year, which was near Gamma Leonis, declination 20 degrees, right ascension 150 degrees. This point was not observed to vary in position for at least 3 hours, thus corresponding to the conclusions which were made out respecting the radiant last year, a circumstance from which it was inferred that the source of the meteors was beyond the influence of the Earth's rotation, and consequently beyond the atmosphere. Professor Olmsted couldn't have proved that the meteor shower originated from outside our world without the help of the thousands of observers who shared their data with him, making the 1833 storm a watershed moment in the history of citizen science. It showed that the public could play a vital role in scientific research. Citizen science has since become an important tool in astronomy, and is now used to study a wide range of celestial phenomena, including comets, asteroids, and galaxies. The 1833 Leonid meteor shower was also an important event for the history of Boston. The shower was witnessed by many of the city's most prominent citizens, including the writer Ralph Waldo Emerson and the astronomer Benjamin Pierce. The event may have helped inspire Emerson to write his famous poem Nature, or led Pierce to advocate for Harvard to establish an observatory. The 1833 Leonid meteor shower also had a significant impact on popular culture. The shower was widely reported in newspapers and magazines, and afterward it inspired poems, songs, and paintings. As an example, I'll include 3 contemporaneous woodcut prints of the meteor shower, including one supposed to be taken from Boston, in the show notes this week. The shower helped to popularize astronomy and to make the public more aware of the wonders of the universe. In a paper about the 1833 meteor storm, Mark Littman says, "In today's parlance, Olmsted was a remarkably successful early practitioner of scientific crowdsourcing, also known as citizen science. He may have been the first to use mass media for crowdsourcing in science. He pioneered many of the citizen science crowdsourcing practices that are still in use today. An open call for citizen participation, a clearly defined task, a large geographical distribution for gathering data, and a rapid response to opportunistic events." Examples of citizen science these days include monitoring bird populations, transcribing historical documents like the glass plate photos taken by the Harvard Observatory in the 19th century, documenting the effects of the Deepwater Horizon oil spill, and even small projects, like the morning I spend each month collecting water samples from a tributary of the Neponset for the Neponset River Watershed Association's Citizen Water Monitoring Network. In a 1998 paper, Bob Riddle notes that astronomers Ernest Temple and Horace Tuttle discovered the comet that's now named after them in 1865, and hypothesized that it was the source of the 1833 meteor storm, continuing, "The Leonid shower's spectacular peak nights during November of 1866 and 1867 validated the 2 astronomers' prediction. Different portions of the Earth may encounter Comet Temple-Tuttle's meteor trail in 2 consecutive years because of the Earth's changing position. In 1866, sky observers in Europe noted that the shower's intensity reached an average of 5,000 meteors per hour. In 1867, observers in North America counted an average of 1,000 meteors per hour. Because Temple and Tuttle had so accurately predicted the source of the 1866 and 67 Leonid meteor storm, the storm of 1899 was much anticipated and promoted by the astronomical community. Unfortunately, the Leonids did not display spectacularly that year. As a result, public interest in the storm waned tremendously. Mankind hadn't seen the last of Comet Temple-Tuttle and the streams of meteorites it left behind, however. It turns out that 19th century astronomers didn't have a sophisticated enough understanding of the complex interaction between the orbits of the Earth, the comet, and interference from Jupiter's gravity. Leonid meteor storms were far from over, with Riddle continuing, "During the early 1960s, the Leonid meteor showers started showing an increase in the hourly rate, similar to the intensity of the showers during the 1800s. In 1965, Comet Temple-Tuttle was rediscovered. That year, the shower's intensity climbed to over 100 meteors per hour. 1 year later, on November 17, 1966, the most intense meteor storm recorded in history occurred over the Midwestern United States. Its average intensity was several thousand per hour, And at one point in the storm, rates were estimated at more than 100,000 meteors in a 20-minute period. There was increased meteor activity again in 1999 through 2001, though it didn't come anywhere close to the amazing display of 1833 or the even more amazing show in the skies in 1966. But it helped astronomers understand the different streams of meteorites that have been left behind each time Temple Tuttle passed the Earth. And that in turn helped them predict future meteor storms. Basically, each time the Earth passes through the remnants of the comet's tail, we pass through a narrow band of meteors that were left by each passing of the comet. So the impressive displays in 1833 and 1966 were caused by the meteors left behind by the comet in 1800 and 1899, while the less impressive displays are the result of passing through older bands of meteorites that have had more time to disperse into space, such as the lackluster 2008 meteor shower, where the Earth passed through the meteorites left behind in 1466. While the annual Leonid meteor shower is fun for amateur skywatchers like myself, it can't hold a candle to the fictional Eye of Aldhani from the Star Wars universe, except during one of the 33-year storms. As I prepare this episode, I've also been experimenting with Google's new Bard AI engine. If anyone's been paying attention to the show notes, you may have noticed a few months ago that I started using an AI product to help generate content tags, chapter marks, and recently a table of contents for the transcripts. Bard's a conversational AI, similar to ChatGPT, and I had it generate a couple of paragraphs at the beginning of the show describing the Eye of Aldhani for non-Star Wars fans. I also had it draft a couple of paragraphs that I used in the middle of the script about the Leonids, and then I asked it to compare the 1833 Leonid meteor storm to the Eye of Aldhani. I assumed that I would get a visual comparison between the two, but I didn't specify that, so the AI engine came up with this instead. The 1833 event helped to establish the idea that ordinary people could play a valuable role in scientific research, while the Eye of Aldhani established the idea that ordinary citizens could fight back against an oppressive galactic empire. Pretty neat, huh? The next Leonid meteor storm that might rival the fictional Eye of Aldhani will light up the night in 2033, as we pass through the meteorite streams left behind in 1899, and an even bigger one's expected in 2034, when we'll encounter the remains of the comet's tail from 1932, which was practically yesterday in astronomical terms. This year, there's a slight chance that we'll see a few more shooting stars than usual as we pass through the remains of the comet's 1767 passing on November 17, 2023. The hardest part will be finding a nice dark spot away from city lights. Once you're there, follow these simple instructions from NASA. The Leonids are best viewed starting at about midnight local time. Find an area well away from the city or streetlights. Come prepared for winter temperatures with a sleeping bag, blanket, or lawn chair. Orient yourself with your feet towards the east, lie flat on your back and look up, taking in as much of the sky as possible. In less than 30 minutes in the dark, your eyes will adapt and you'll begin to see meteors. Be patient. The show will last until dawn, so you have plenty of time to catch a glimpse. You should not only look to the constellation of Leo to view the Leonids. They're visible across the night sky. It's actually better to view the Leonids away from the radiant. They will appear longer and more spectacular from this perspective. If you do look directly at the radiant, you'll find that the meteors will be short. This is an effective perspective called foreshortening. To learn more about the Leonid meteor storm of 1833, check out this week's show notes at hubhistory.com/287. I'll post a woodcut image of the 1833 meteor storm as seen from Boston, plus 2 more that Olmsted included in his report, so you can compare them to the fictional Eye of Aldhani. I'll also include all the primary sources that I quoted from, including Professor Olmsted's report and a half a dozen contemporaneous newspaper reports on the meteor storm. Along with those, I'll also link to Sidney Purley's Historic Storms of New England, as well as the modern papers I cited, from Helen Sawyer Hogg, David Hughes, Bob Riddle, and Mark Littman. If you'd like to get in touch with me, you can email podcast@hubhistory.com. We're Hub History on Twitter, Facebook, and Instagram, and I'm still most active on Twitter. If you're on Mastodon, I have an account as @hubhistory@better.boston. Or just go to hubhistory.com and click on the Contact Us link. While you're on the site, hit the subscribe link and be sure that you never miss an episode. If you subscribe on Apple Podcasts, please consider writing us a brief review. If you do, drop me a line, and I'll send you a Hub History sticker as a token of appreciation. That's all for now. Good luck and happy stargazing. Stay warm out there, listeners.